In this lesson, we will learn about translating graphs. So what is translation? Translation is a movement of the graph. So it can be in the x-axis or y-axis, or it can be x and y-axis as well. So if you write any formula as a function, so fx is equal to x squared, so that's the same as y is equal to x squared, then it's easy to apply translation to this formula. So translation parallel to the y-axis, that means the graph is moving up or down, not sideways. So if x is equal to x squared, then fx plus a is equal to x squared plus a. Make sure that a you are adding is to the whole function, not to the x. So the whole function you are adding a. That's why you are getting x squared plus a. But if you add a to the x, then the a will go into the inside the bracket. See, it's going to be x plus a. So you have to replace the whole x with every x you need to replace with x plus a. This is not the case. You are only adding a constant a to the whole function. So this will provide the translation to y-axis, the parallel to y-axis. Say for example, fx is equal to x squared. Then if you're adding 3, the constant 3 to the whole function, then that will produce another graph parallel to the y-axis. So the red graph is fx is equal to x squared, then fx plus 3, that is x squared plus 3, that will be the green graph that's moving upwards, the 3 units upward in the y-axis. So we will look at another example. So fx is equal to x squared, then fx minus 2, you are minus 2 units, you are minusing it from the whole function. Then that will produce the graph x squared minus 2. If you draw them, the green graph is the translated graph, red is the original one. So it's going 2 units down in the y direction, the y-axis. So fx plus a represent the translation through a vector called 0, comma a. So 0 x direction and a y direction. So in this case, it's going to be 0 minus 2. A is going to be minus 2. So the translation to the parallel to the x-axis will happen if you replace the x value. You are changing the x value, you are not adding to the whole function. You are adding a constant to the variable x. So if x is equal to x squared, then the translated graph f of x plus a is going to be x plus a squared. You are replacing x with x plus a squared. So if the a value is positive, then the graph will move to the left. If the a is negative, the graph will move to the right. We will look at one example. So if x is equal to x squared, so you are adding 3 to the x. So the new graph, the translated graph, is going to be x plus 3 to the power square. You are replacing the x with x plus 3. You are not adding 3 to the function. You are adding 3 to the x variable. So x squared is the red graph that is touching the 0, 0 point. But x plus 3 squared is going to move on the left hand side, 3 units on the left hand side, parallel to x-axis. So we will look at another example. So fx is equal to x squared. Then the translated graph f of x minus 2, you are replacing x with x minus 2. Then that graph is going to be x minus 2 to the power square. You are replacing the x with x minus 2. Then the graph will move to the right hand side. The red is the original graph x squared. The green is the translated graph that is moving 2 units right hand side on the parallel to the x-axis. So the translation vector is going to be minus a0. Okay, so x, it's moving minus a on the x direction and 0 in the y direction.